Hello all, welcome back. In the last video, I have given a brief introduction about engineering mechanics. In this video, I'm going to give definition that we are going to use in definition for the terms that we are going to use in engineering mechanics. So I'm going to start with velocity. So velocity is nothing but it's a measure of object speed as well as direction of motion. So unless speed, velocity has both magnitude and direction. So velocity is a vector quantity. So I want to explain it with a simple example. Consider one lamp post here, and if a person moves at 7 km per hour, for an example, then this 7 km per hour is a speed, but he is going away from the lamp post. So this is considered as a velocity. If we mention the person's speed only, that is speed. It's a magnitude only. But if you are mentioning the direction like going away from this lamppost means that's considered as a velocity. So there is another important term in velocity is called as relative velocity. So relative velocity is nothing but velocity between two moving objects. See, there is another person moving at 8 km per hour means what is the relative velocity between these two objects? Let's consider as a person A, person B. See, since they are moving in opposite direction here, we have to add this to velocity. 2 km per hour is their relative velocity. Why? Because if they travel for 1 hour, the person A would travel 7 km. The person B would travel 8 km. So what might be the distance between in 1 hour? Distance between the two persons is 15 km per hour. That's what I mentioned as a relative velocity. If they are moving in the same direction means, see for an example. Okay, if a person moves in this direction means person A at 7 km per hour means we need to subtract the velocity because after 1 hour the person B would reach 8 kilometers from here and person A would reach 7 km. So the distance between them is 1 kilometer in 1 hour. So this is called as relative velocity. So since they are moving in the same direction, we need to subtract 8 minus 7 is equal to 1. That's the relative velocity. They moving in the same direction, we need to subtract the velocity. They moving in the opposite direction means we need to add the velocity. So that's all about relative velocity. Here unit of velocity is meter per second and we can also mention as kilometer per hour. So basically it's a distance divided by time. So next we are going to see about acceleration. Acceleration is nothing but rate of change of velocity. How velocity changes with the time. Rate of change of velocity. Please dv divided by dt. Acceleration. So unit of this acceleration is meter square per second. So it's also a vector quantity. It has both magnitude and acceleration. So if the acceleration in negative direction, we call it as a deceleration. And if we want to explain the acceleration, consider this example. A person A, he travels at u velocity, but he has to increase his speed to velocity of v. So initially the time would be t naught. When he attains the velocity v, his time would be t1. to calculate acceleration of this person, we should consider the change of velocity. dv means the change of velocity, which is v minus u here, and dt change of time, which is t1 minus t0. So this is considered as a velocity. So if a person is start from the rest means his initial velocity would be 0 and the initial time would be also 0. So a would be v divided by t. So we can also mention acceleration is a slope in the velocity time curve. What does it mean? Means, see, there is a, let's say an example, this is considered this is a cricket ground. So this is a pitch and batsman is here. After the batsman hits the ball, let's assume the ball moves in this direction and there is a one fielder is here. So after the batsman hits the ball, he chases the ball and take the ball here and he give it to the this end. Let's assume like that. So initially he would be at rest, right? At initial time he would be at rest. When t is 0 equal to 0, velocity is 0. So initially he's at rest. So after the he's seeing that batsman hit the ball, he has to increase his velocity in this direction. So his velocity starts increasing. So when he reaches like this position, he has to reduce his speed. Otherwise, he would, if he travels on the same maximum speed, he cross the rope. He couldn't pick the ball and throw it back to the this bowler end. So what he doing means he has to reduce his velocity to 0, and only he could pick the ball and throw it to this end. So this is a graph of this person's velocity per time. So this slope is called as acceleration. See, if you consider this, this is initial velocity, this is final velocity means v2 minus v1, and this is as t2 minus t1 means this is called as acceleration. See here the velocity is increasing, the positive slope, so it is called as acceleration. If you consider same slope here, not a same slope here, it will call as deceleration. So this is what the difference between acceleration and deceleration. Here he is reducing his velocity. Here its velocity is increasing. Here is a positive slope. Here is a negative slope. So acceleration is also the slope of the velocity time curve. Next we are going to see about momentum. Momentum is simply is a product of mass and its velocity. So why we need to consider momentum is momentum has directly proportional to impact created on object. See, if one object has high momentum means it will create huge momentum in another object. And also if you want to stop one object which is moving at a m1 momentum means, and like let's say in this direction, and if you have to apply a force to stop this object, the opposite force considered as a F1. This F1 is totally dependent on this momentum. So if the momentum is high means we need to apply more opposite force to stop this vehicle. So that momentum is directly proportional to the opposing force. As I mentioned, so momentum is product of mass and velocity. Since velocity is here, it is also a vector quantity. Then the rate of change of velocity is the rate of change of momentum is equal to force. It is derived from Newton's second law. The rate of change of momentum means mass into velocity is force, which is derived from Newton's second law. So what does that mean? Means, see, if the object's mass is constant, means we take it out, and this is force. So dv divided by dt is, we know that it's the acceleration. So F is equal to mn. So this is what we know as a Newton's second law. But the actual definition is the rate of change of momentum is equal to force. And that's a Newton's second law. Here I want to explain another term called inertia. So what is inertia means? It's a force applied to change object's speed, object's motion. It may be either rest or moving. See, if is there one object, it is in rest means if you want to change its motion of rest into motion means then we have to give a force. That force is called as inertia. So why I'm explaining it here means, see, this inertia is also depend on how much moment it has. See, if there is one object which moves at a particular momentum means that inertia is totally depend on the momentum that the particle or an object has. If one object has high inertia means it has high resistance to change its motion. So inertia is means it's a resistance to change its motion, either it's a rest or it's moving. So next we are going to talk about continuum. Continuum is just an assumption that a body has a continuous distribution of matter. Why? Because means it's why we are assuming like that. It's easy to calculate. If a body has a defect, see, everybody has a defect, but if we consider those defect means you can't take it for a calculation. We should consider that defect it has means it would make the problem more complicated. So we just assume like that the body has no defect. It has a continuous distribution of matter. So it's called as a continuum. So next we are going to see about force. So force is an influence that can change the motion or rest of an object. Because if there is one example, taken one object, it is in stationary. To move this object from here to here means then we need to apply some force on it. So that this force will cause this object to move from here to here. And also force has a ability to change the direction of an object. See, if you see in cricket, the ball comes to the batsman, but he hit it anywhere he wants. The ball comes in this direction, but he hit in the mid wicket or in the straight or here or here. He can get anywhere because he is giving the force in this direction, means the ball will go in this direction. So this force has ability to change objects motions also, sorry, objects direction also. So what are the characteristics? How do we define one force? Take one beam for an example. First of all, we should consider force magnitude, right? It is a vector quantity, so it has a magnitude. Maybe consider it as a 50 kilonewton, and it has a direction. See, there is a difference between this force and this force. So what's the difference means? The direction in which the force is applied. So we have to define it with magnitude and a direction, and also the line of action. So what is a line of action means? That's a angle in which the force is applied. See, there is, let me draw a new diagram. See, there is one beam. There's a difference between this force and this force. What is the difference between F1 and F2? The angle. Here is angle approximately to 90 degree. Here it might be to 60 degree. If you draw the line of action, that is the extension of this, it will be different. So it will create different impact on this beam. So we should also consider the line of action. And one more thing is also there. It's a point where the force is applied. See, let's say this is x1. Let's take another distance from here, x2. If the same magnitude force acting here and here means, let's say this is F1, 50 kilonewton, this is 50 kilonewton means this force has same magnitude, same direction, same line of action, but the point of application is different from here and here. The distance between this x1 and x2. See, this is considered as a x3. So difference between these two forces is called x3 here. So since the point of application is different from here, it will create different impact on this beam. So we should consider the point of application also. So these four things is very important to define one force. So if you want to define one force, we should consider its magnitude and its direction and line of action and point of application. So next we are going to see the rigid body. We already discussed it in this topic on a previous video. Rigid body is nothing but it would retain its shape when external forces applied to it. You can take an example, crankshaft, bearing, piston, it would retain its shape. There might be a negligible deformation, but we don't consider that negligible deformation. In further, rigid body means that if you take one body like this, if you take 2 points, let's say point A and point B, the distance between these 2 points is called as D. This D won't change throughout its application time. If this D would change means we call it as a failure. So rigid body is nothing but it would retain its shape during the application of external force. If it's change means we consider it as a failure. Then particle, it's an object with mass but no size. So practically it is not possible. We can't find any particle with no size but mass. So particle it's an imaginary concept we took it for calculation.
So here I told like that point A and point B, we consider here it as a particle, but we don't have real, example for that. It's only for the calculations. So this is all about this video. So, so I'm expecting your comments in comment box. Thank you.